Hey there! We are going to be talking about transformations in this video, transformations of parent functions. So let's look at this parent function that I have here on the board. Can you name that parent function? Hopefully that's a yes. This would be y equals x squared, or f of x equals x squared. It is the parent function for the quadratic functions. Okay, so let's look at some transformations of this graph of y equals x squared. Let's say that we have y equals x minus 2 in parentheses squared. I want you to think about how that affects the graph and compare that to the parent function y equals x squared. So I'm going to just trace right over this guy. What does the minus 2 in the parentheses do to the graph? I want you to be thinking about these answers before I say them. What it's going to do is it's going to shift our graph 2 units to the right. So the vertex moves from 0, 0 to 0, 2. And one way to think about that, because it seems like it's going the opposite direction is what you would assume because it's a minus. But if you think about so with the original function, when x is 0, here's my original function. When x is 0, y is 0. But for this transformed function, when x is 2, y would be 0. So it moves 2 to the right, positive 2. All right, so when you have something in the parentheses, and this is something to note, in the parentheses is always going to be horizontal. Outside of the parentheses is going to be a vertical transformation. So subtracting 2 inside the parentheses moves it 2 to the right. I want you to look at the next graph. What is going to happen when you add 3 on the outside of the function after squaring? And what that'll do is it will take this function and it will move it up 3 units. So outside the parentheses after the function, which is the squaring, it moves it up or down vertically. So this would shift up. I didn't write down. Shifts up 3 units, or transformation 3 units up. Translation is another term for that. Let's actually write that. Or you could call it a vertical translation. And in this previous one, it was a horizontal translation. Two units to the right. Okay, so in the next one, f of x equals 3x squared. That is going to actually transform the shape of the function. So we have, in the parent function up here, we have an a value of 1. And here, the a value has changed to 3. So what that means is everything is going to be stretched 3 times in the vertical direction, so 3 times taller, essentially. So if 0, 0 is part of the graph, if you stretch the y-coordinate 3 times bigger than 0, that's still going to be 0. So the vertex stays at 0, 0. But on our parent function, we have the point 1, 1. That is now going to become 1, 3. So it gets stretched up 3 units in the vertical direction. So every y-coordinate is going to be 3 times taller than the original function. So when I move over 1, I'm going to go up to 3 instead of up 1. And in the parent function, when we go over 2 units from the vertex, you go up to 4. So if you, with the a value being 3, then instead of going over 2 and up 4, we're going to go over 2 and up 3 times that amount, so up 12. And that's off my graph, so I'm just going to draw in this. It looks narrower, but really what it is it's stretched taller. So it is called a vertical stretch. Let's see if I can fit that in here. Vertical stretch of factor 3. All right, and then this last one here has several different transformations. We have a negative. What that's going to do is flip over, again, let me use the more technical term, reflection over the x-axis. So again, it's vertical. When the negative's on the outside, it flips it over x vertically. If the negative were on the inside here, then it would be it would flip over the y-axis. All right, so then also we have, so that's part of the a value. It makes it flip, it makes the parabola open upside down and have a maximum value instead of a minimum value. Okay, I'm sorry. All right, then the 1/2 is going to affect the graph. The y coordinates are going to be compressed this time, half as tall. So vertical compression, and some books use different terminology, but vertical compression works of factor 1/2. So everything is half as tall as it was. The +2 on the inside of the parentheses, remember that's going to be a horizontal, it's a translation, so it translates left, and that's horizontal. I should write that also. Horizontally translates left 2 units. Again, we're adding 2, but it goes in the negative direction, so it's always opposite when it's on the, when anything that's horizontal, I mean, yeah, the horizontal transformations are always kind of different than what they seem like they should be. And then this last piece here, the -1, I'm running out of room. I'm going to do this. -1. It's a vertical translation. One unit down. Okay, so it's vertical because it's after you've squared. So let's graph that. We have, let's go to the vertex. So the vertex is going to change. We're going to have a vertex that moves from 0, 0. If it moves left 2 units, it's going to have, the x-coordinate is now going to be -2, and the y-coordinate is going to be -1. So -2, -1 is right here. It's opening downward because of the negative. And when I go over 1, instead of going down 1, I'm going to go down 1/2 because it's 1/2 as tall, but in the negative direction. And then the parent function, we go over 2 from the vertex and up 4. We're going to go over 2, and we're going to go down half that amount, so down 2. And our parabola will look something like this. Okay, so let's generalize that. Before I do that, though, let's look at what this is. Don't write this down yet. I also want you to decide whether or not the transformation is rigid or non-rigid. Rigid transformations shift the graph left, right, up or down, or reflect the graph over x or y, but it does not change the shape. Non-rigid transformations change the shape of the graph. And that'll be when you have vertical compressions or stretches, or horizontal compressions or stretches. All right, so write this down. Rigid transformations, the shape stays the same. Non-rigid transformation, it changes the shape of the graph. Rigid meaning it's stiff and it doesn't change. And non-rigid means it's fluid. It can change its shape. Okay, so this is the generalized version of what we were doing with the quadratic function. For any function y equals f of x, describe each transformation, and we're going to just assume that c is greater than 0, and we're going to also decide if it's rigid or non-rigid. So if you have this scenario here, f of x plus c, I'm adding the c after the fact, what kind of transformation is that going to be? It will go up c units because we know that c is positive. And that'll be a rigid transformation. Oops, I did not mean to change the color of that. That's okay. All right. And if you subtract c, that's going to shift it down c units, and that will also be a rigid transformation. Inside the parentheses, when you have f of x minus c before you perform the function, like the squaring, that is going to shift the graph right c units, and that will be rigid. And if you add a number inside the parentheses, it's going to shift left c units and also rigid. Number 5, multiplying by c on the outside. It's outside before you do the function, so that means it's going to be vertical. It is a vertical stretch of factor c or a vertical compression. And some books, like I said before, they'll use just the word stretch, and if it's a vertical stretch of factor 1/2, you know that really it's getting compressed. This is a non-rigid transformation because it changes the shape. So if c is greater than 1, it will be a vertical stretch of factor c, and if c is between 0 and 1, then it's a vertical compression. So greater than 1 is a stretch, between 0 and 1, so a proper fraction, is a compression. And if it equals 1, then it's the same as the parent function. Okay, number 6 here, we have, a negative on the outside. So again, since it's on the outside, that will be vertical. Hold on a second, let me get rid of that. A vertical. All right, so let's look at number 6 here. That is a reflection over the x-axis, and that is a rigid transformation. It's flipping vertically because the negative is on the outside. Remember, anything on the outside is going to have a vertical effect. Anything on the inside of parentheses before you do the function is going to have a horizontal effect. So number 7, horizontal, because the negative is on the inside, and it will reflect over the y-axis, and both of those are rigid transformations. Okay, and then number 8 here. This one is one that we haven't covered a whole lot, so I will do a quick review of that in another video because we're not going to have time here. But if you have a multiply by a number on the inside of the parentheses, it's going to have a horizontal compression or stretch. And c, if c is greater than 1, so the bigger the number, the more of a horizontal compression you're going to have. So everything inside, all the horizontal stuff always seems like opposite of what it should be. And it's going to have a horizontal compression of factor 1 over c, and that's if c is a number greater than 1. And then here, if it's between 0 and 1, so a proper fraction, like let's say 1/2, that's going to actually be a vertical stretch of factor 1 over c again. So if c was like 1/2, then you would take the reciprocal of that and would have a vertical stretch of factor, a horizontal stretch of factor 1 over c. So if you have your parabola, and let's say that we have 1/2 on the inside, what it's going to do is it's going to take all of your x coordinates and stretch them twice as wide as the original. Okay, so here's what you need to do. Actually, let's review these parent functions really quickly. You have linear function in purple here. We have the absolute value function. We have a square root function, and then the quadratic function. And this is all on page 41 in your textbook. So you can review those if you forgot what those look like. We have several other parent functions that we will be getting to throughout the year, but this is a start. And then what I'd like you to do is check for understanding, do the 1.4 practice. You can find it in Canvas or get it from me in the classroom. Okay, so I'm just going to do one quick example here. Here's a function that is not an actual, it's not a parent function, but we have this graph here, and so if this was f of x, and if, for example, you're asked to take f of x and add 2 to it, that would be a vertical, and it's much easier when I have a smart board, but it's going to be a vertical translation up 2 units. So if I take this where it's at -1 and I just drag that up 2 units, with your pencil you have to just take each point and raise it 2 units and then connect the dots. We can go over questions in class.